For our second example, we're going to start by dividing by -3 on both sides. And we get the absolute value of P is equal to +4. When we go to split this, our first one we keep exactly the same. The second one, we drop the absolute value bars and negate the other side, so it becomes a -4. Conveniently, this one's already solved out for us. So we can immediately plug both of those in to be checked. -3 times the absolute value of P is equal to -12. -3 times the absolute value of P is equal to -12. First time I'm plugging in 4. The absolute value of +4 is +4, so 3 times 4 is equal to -12, and -12 is equal to -12. Checks out. The second one we're plugging in -4. The absolute value of -4 is still +4, and -12 is equal to -12. It checks out. Our answer is 4 and -4. All right, let's move into slide 5. Here's our first example. 3 times the absolute value of -8 plus 8 equals 80. All right, the first thing that we're going to do in order to isolate our absolute value, just like a two-step equation, is to subtract the 8 on both sides. So we get 3 times the absolute value of -8x is equal to 72. We'll divide by 3. And the absolute value of -8x is equal to 24. We're now going to split it into 2. First equation, exactly the same, just drop the absolute value bars. -8x equals 24. Second equation, drop the absolute value bars. -8x is equal to, in this case, -24. Divide by -8 on both sides. X equals -3. Divide by -8 on both sides. X equals +3. We're now going to move this into our check. Again, always the original equation. 3 times the absolute value of -8x plus 8 equals 80. Three times the absolute value of -8x plus 8 equals 80. So the first time I'm plugging in a -3. What we do inside first, 3 times +24 plus 8 equals 80. Take the 24 out of the absolute value. And 80 does equal 80. Checks out. On the other side, we are plugging in a +3. the absolute value of negative 24 is positive 24. And you end up with 72 plus 8 equals 80. 80 equals 80. And it checks out. Your two answers here are negative 3 and positive 3. And finally, our fourth example. The first thing we have to do on both sides is add the 3. And we get the absolute value of x plus 1 is equal to 3x plus 3. Alright, we split it into two equations because we've isolated our absolute value. The first equation stays the same, x plus 1 equals 3x plus 3. The second equation, you drop the bars, x plus 1 equals, and now we have to negate the other side. That's each term must be negated. So negative 3x minus 3. I'm going to go back and solve my first equation. I'm going to subtract x on both sides. 1 is equal to 2x plus 3. Subtract 3. Negative 2 is equal to 2x. Divide by 2. X equals negative 1. On the other side, I'm going to add the 3x. And I get 4x plus 1 equals negative 3. Subtract my 1. 4x equals negative 4. Divide by 4. X equals negative 1. So in this case, we actually ended up with the same answer for both equations. It's not a big deal. It actually works out nicely because it means you only have to do one check. Alright, I'm plugging in negative 1. Negative 1 plus 1 minus 3 equals 3 times negative 1. The absolute value of 0 minus 3 equals negative 3. The absolute value of 0 is 0. And both sides of this equation become negative 3. So our only solution here in the solution set is negative 1. If you missed any part of these notes, this video is again on my website, and please at some point this weekend go back and finish them up. Make sure you have everything copied for Monday's class. The next slide we will take care of on Monday. You are not responsible for the final slide, just up through these 4 problems. Thank you.